Assalamualaikum and hi. My name is Muhammad HAZIQ TF210065. So today I'll be going to present about introductions for our group project. So let's get started. So I'll start off with the first part of the introductions, which is I will be explaining about the relationship between rainfall and flood. So first of all, what is flood? Flood is a natural phenomenon that occurs at more or less at intervals in all river basins all around the world, which is serve important in natural ecosystems. Flooding, on the other hand, is the primarily thought of a bad rather than a beneficial phenomenon, which is it entails specifying damages for various elements at risk, such as residents, public spaces, and industries, as well as transferring solutions of a space from one region to another region and time from one to another, which is flood also has a long term of health consequences, which is including drowning, physical trauma, infections, and chemical risks, as well as implications on people's well-being, livelihood, and social cohesion. It is not always simple to pinpoint a local repercussions of floods, such as the effects of displacement, property devastation, delayed recovery, and disruptions of healthcare services. Flooding can also harm key infrastructure and disrupt health, social care services, as well as supply lines from business. So I'll be explaining the second part for the introductions, which is catchment area. If you are wondering, what is catchment area? So catchment area is a region, a land area that bordered by hills that gathers water after a downpour, which is raining. Water runs downhill and accumulates in rivers and streams in these locations. This is a crucial lens for examining a location because water movement has an impact on much of the terrain, foliage, and ecosystem. This can aid with drainage, basin information, and water flow. This is the same notation that underpins trade area analysis, often known as catchment analysis. Watersheds are dividing lines between the catchment regions. A watershed is a natural division line that runs parallel to an area that has a higher peak along the line of the elevation catchment and separated into a sub-catchment, which is I will be show this image for the area catchment. So for the last part for the instructions, I will explaining about the background studies for our group project. For each group has been tasked with analyzing one case site relating to flooding in that region, which is using the map provided by Public Info Banji. We have chosen 3 rainfall stations and 1 water level station closest to a river in Malaysia. The following are the 3 stations and 1 water level station, which is the first one is Ayuni Puchong Jaya, the second one is Sungai Kelang USG1, and the last one is Puchong Drop Point, which is for the water level station we pick Sungai Kelang USG1. The region that I'm showing here is one of the areas that impacted by floods last year, which is ideal for our group projects. In addition, being one of the 8 main rivers in Kelang, Selangor, the rivers have been subjected to several river pollutions, which is caused by human activities. In addition, we picked this place for a number of reasons, which is including the fact that the station was situated in the heart of city and it was simple to collect the essential information or data. Additionally, these 3 stations were next to one another.
Assalamualaikum and hi, my name is SYAFIOAH RAHMAN, number metric TF210034, and I will continue the presentation for methodology part. As for the method, we collect the data for daily rainfall by the total rainfall of the day and water level on the graph by gathering the water level readings. Then, record the reading, and if there is a rainfall of a certain time, then a reading every 1 hour will be taken. All the data are taken at Public Info Flat and the Selangor Drainage and Drainage Department as beacon as JPS Selangor. Next, we use Google Earth to draw catchment boundary of the station that we're choosing from website Public Info Banji. Aside from that, we must create a topographical profile and gradient slope in Google Earth, as well as 3 cross-section of a river at the water level from the station that our choice. In addition, we calculate the rainfall data by using arithmetic mean rainfall by dividing the sum of the element of a set by the number of values in the set. where P is average precipitation depth in millimeter, Pi is the precipitation depth at gauge within the topographic basins in millimeter, and N is the total number of gauging stations within the topographic basin. The second method is distinct polygon method, generated from a set of sample points such that each polygon defines an area of influence around its sample point, so that any location inside the polygon is closer to that point than any of the other sample points. Where P is the average precipitation depth in n millimeter, Pi is the precipitation depth at each station in millimeter, AI is sub-area at each station as polygon area, and A is the total area. That's all from me. Thank you. I will pass the presentation to the next presenter.
Thank you for the past presentation. Now I want to continue this presentation. My name is Nurul binti KAMRI, metric number DF210071. Now I want to explain about Isohyetal Method. Isohyetal Method is generally used for analysis of rainfall, usually localized over small area with a large range of rainfall amount on short distance. Use this formula. P is average precipitation depth in unit m, PIE average precipitation between two isohyetal lines in unit m, AI is sub-area between two isohyetal lines, and A is total area. Next, I want to explain about stream flow or water level. In stream flow or water level, I have 3 steps. Firstly is use rational method. This method is for purpose the highest runoff produced in the stream. Second method is calculate the overland flow time TO. TO use this formula where TO is overland sheet flow travel time in unit minute, L is overland sheet path length in unit meter, N is Horton roughness value for the surface, S is slope overland surface in unit percent. Third is calculate the peak flow Q. Q use this formula where I is rainfall intensity in unit mm per hour, C is runoff coefficient, unit A is watershed area in unit hectare, Q is peak flow in unit meter padu per S. That's all for me. I pass this presentation for next presenter.
Assalamualaikum warahmatullahi wabarakatuh. My name is FARHAN from LATIFF. Today I will present you a data presentation in data analysis for our group. Okay, for this project, we need to select the 3 rainfall station and 1 water level station for this project. The data for these 3 rainfall station and 1 water level station is recorded in Excel, and for the rainfall data is for unit per meter and water level data in meter unit. And these data are recorded by 4 weeks, which is from 17th of April until 14th of May 2022. Okay, we go to the next slide. Okay, the station selected is, you can see, the three above is for the rainfall data, and the one is for the river data. Okay, this group of table, you can see this is the data collected by 4 weeks, and this is the dates, and these are the 3 rainfall station, which is Ayuni, HAQIMI, and Road station. The data collected are in millimeter as Ayuni. Here is the water level data for HAQIMI. This is the table, and these are the reading in meter, which is in hours. You can see, and this is the example of for our group data. So next, for the analysis for the rainfall data, we need to use the 3 method, which is arithmetic method, statistical method, and the Isohyetal method. For the arithmetic method, we need to use any of the 7 data, any of the 7 days data for the rainfall data. And for the statistical method, we need to find the area. And for the Isohyetal method, we need to find interval, precipitation, and area. For the water level of the rainfall data, we need to do a graph of 4 weeks of water level station data. Okay, for the rational method, first we need to determine the IDF curve, which is the overall time, and this is the formula. Second, we need to find the peak flow Q based on the data obtained. So the data obtained is here. We need to find the rainfall coefficient, which is C, and average rainfall data intensity, height, and catchment area. After we get this value, we just sort it into the formula, and this is the value for the cube. Okay, we go to the slope area method. For the slope area method, for the first thing, we need to find the slope of the river. Second, we need to calculate the parameter for each cross section. For our group, we have 3 cross section, and the shape is trapezium, triangle, and rectangular. Third, we need to determine the main roughness coefficient, which is n, and or we need to calculate the discharge based on the area of subsection and the slope. As you can see the table below, this is the data that we obtained to find the slope area method. The main roughness is only the same because we use the same. I already told you about the cross section, which is our group have a 3 cross section for this group hydro project, and it is an example, which is cross section 1 for the river. And thank you.
Hello, Assalamualaikum, and very good day. I am Muhammad ASRAF bin NORDIN, and I would like to present to you about the discussion and conclusion of the project from Group 9. This project had been studying the determination about the relationship between the rainfall and flood discharge probability. It has been successfully done by 2 views of the project. First, the literature review or research, which had been done by the journals, the research paper, also the technical paper. And the second one is the calculation on data sample by using 3 rainfall data station and also 1 water level point. This data sample had been calculated by 3 methods. First is arithmetic mean rainfall method, second is Tyson polygon method, and the third one is Isohyetal method, which had been successfully done and calculated and analyzed. According to the past research paper and the analyzed data, flood is a natural disaster that related to the rainfall and water catchment area. Therefore, to avoid flood, reduce the risk of the flood or this natural disaster, there had been few suggestions. First, increasing the civilization of public awareness about the disposing waste properly and not into the river. Second, on the government and the certain authorities to build or design a better drainage system to have a good flow of water. And the last suggestion will be the maintenance on the drainage systems by the contractors and workers. Therefore, we can conclude the importance to determine or to comprehend the relationship between rainfall and flood discharge probability by this project to avoid the flood and to sustain the civilization. That's all from us. Thank you.